Hi, 8th grade. So today during conferencing block, we're going to be doing some problems to help us get ready for our MLQ tomorrow. So you should have a worksheet that says 8.31 conferencing block MLQ prep. All right, the first problem says estimate square root of 71 to the nearest 10. So the first thing I need to figure out is what two numbers is the square root of 71 between. Right, it will be between 8 and 9 because 8 is the square root of what? 64, and 9 is the square root of what? 81. All right, so I know that it will fall somewhere between these two numbers, and I need to figure out exactly where it will fall. So, is it going to be closer to 9 or closer to 8? It's going to be closer to 8, because this is how far away from 64? This is 7 away from 64, and 10 away from 81. So it's going to fall closer to 8, but it's also going to be pretty close to the middle. Because if this is 8.5, that would be 8.5, that would be right in the middle. So what do you think the best guess is? 8.8, 8.6, 8.4, 8.2, or 8.1? The best guess is going to be right around here with 8.4. All right, for this next problem, we are comparing two numbers and trying to figure out which one is bigger. So we're going to fill in these blanks with less than, greater than, or equal to. Remember, the less than and greater than signs always eat the bigger number. So the open side goes towards the bigger number. Looking at this first one, we have a decimal and a fraction. I don't know how to compare these two by just looking at them, so I need to convert my fraction to a decimal. This fraction bar means division. So I can convert it to a decimal by doing top in, bottom out. 5 goes into 20, 5 doesn't go into 2, 5 goes into 24 4 times. 5 times 4 is 20, subtract, bring down a 0. 5 goes into 40, put my decimal up top as well. 5 goes into 40 8 times. And so 24 divided by 5 is the same time as 4.8. So these two are equal. For this next one, try and figure it out on your own before we do it together. Okay, so can I do the cubed root of 8? Yeah, the cubed root of 8 is equal to 2 because 2 times 2 times 2, so 2 cubed equals 8. What about the square root of 5? What two numbers is the square root of 5 in between? The square root of 5 will be in between 2 and 3. Because 2 is the square root of 4 and 3 is the square root of 9. So it's in between the square root of 4 and the square root of 9. All right, so is square root of 5 going to be bigger or smaller than the cubed root of 8? It will be bigger because it's between 2 and 3, so it's bigger than 2. All right, for my final one, I have 3 1/5 and square root of 15. So what two numbers is the square root of 15 in between? The square root of 15 will be in between 3 and 4. If I do my number line, for 3 and 4, 3 is here, 4 is here. Approximately, where does the square root of 15 fall? Will it fall closer to 3 or closer to 4? It will fall closer to 4 because this is the square root of 16, so it'll fall right around there. Okay, so now if we look at 3 1/5, where would 3 1/5 fall on this number line? We can actually divide top in, bottom out, 1 divided by 5 to convert it into a decimal. We would get 0.2. So 3 1/5 is the same as 3.2 because I need to add my 3 back in. 3.2 is all the way over here, so the square root of 15 is bigger. For our last problem, we need to order these 5 numbers from least to greatest. So I want to go through and see if I have any perfect squares or perfect cubes that I can solve really easily. Cubed root of 8. Is 8 a perfect cubed? Yeah, it is. So the cubed root of 8 is what? 2. So I'm going to erase the cubed root of 8 and write 2. 22 divided by 7. That's hard to divide, so we'll skip that for now just until we go through the easy ones. Square root of 15. Is 15 a perfect square? No, so we can't solve this that easily. What about cubed root of 64? Is 64 a perfect cube? Yep, so what's the cubed root of 64? 4. And then 3 and 32/100 is already written as a decimal, so we'll leave it like that. All right, so now I have 292 over 7, square root of 15, 4, and 3.32. I still need help with these two in order to be able to order them. So for 22 over 7, what can I do in order to make it easier to order? Yeah, I can make it into a decimal. How do I make it into a decimal? Top in, bottom out. 7 goes into 22 3 times. 7 times 3 is 21. Subtract. I need to keep dividing, so I will add a decimal and a 0. Bring down my 0. 7 goes into 10 1 time. Subtract 7, I get 3. I can bring down another 0. 7 goes into 30 4 times. I'll get 2. Just because we only need to order them and I don't need an exact number, I'm going to stop right there. So I'm going to stop at 3.14 because that's approximately what 22 divided by 7 is. You always want to go to at least 2 decimal places when ordering them, just in case you have another one that's really close. All right, and lastly, I have the square root of 15. In order to be able to order the square root of 15, I need to estimate what it is to the nearest tenth, which we're really good at. So the square root of 15 will be between what two numbers? Yeah, it will be between 3 and 4. 3 is the square root of what? 9. 4 is the square root of what? 16. The square root of 15, will it be closer to 3 or closer to 4? It will be closer to 4 because this is only 1 away from here, and this is 6 away from here. So what's a good estimate for the square root of 15? 4.8 or 4.9 is a really good estimate. So I can replace the square root of 15 with 4.9. So now my numbers are really easy to order. What's my smallest number? My smallest number is 2. Then I have 3.14. Then I have 3.32. Then I have 4. Then I have 4.9. If I go back and replace all my original numbers in, or my original notation for my numbers, I have cubed root of 8. This was 22 over 7. That was the same. This was the cubed root of 64. And lastly, we have the square root of 15. Oops. I did that wrong. That's supposed to be 3.9. So these two are switched. So square root of 15, and then the cubed root of 64. All right, go ahead and finish the rest of the problems independently. Good luck.